Welcome to this tutorial, and here I'm going to discuss with you the main types of energy. As a student taking applied mechanics, you have to first know what energy means. Energy is the capacity to do a particular work, and in this discussion there are many types of energy, but we are going to discuss the key concepts or the main types of energy that are commonly tested in applied mechanics. So energy is the capacity to do work. Energy is the capacity to do work. And when we look the types of energy, we have kinetic energy, we have potential energy, we have strain energy, we have chemical energy, we have mechanical energy, we also have electrical energy. We have got energy in form of sound and also heat and many others. But in this tutorial, I'm going to tackle kinetic energy, potential energy, and more so strain energy. Let's go. What is potential energy? Our first energy type is potential energy. This is always referred to as the energy possessed by a body due to its position, and also we can say it is equal to the work done in raising the body to the position from a certain datum level. Look here, we have got this diagram. There is an height h of this distance, and when this object is at this position, here there is potential energy. So this body possesses potential energy due to this position when it is at this point. So potential energy is always given by this formula, mgh, where m is the mass of the body, or here mass of this object, and this object is our body. Mass of the body. Then G, this is now the gravitational pull. You can see this body is at this point, and remember it is on the surface of the earth. A gravitational pull is exerted on this body at this point. So this is gravity, while h is the height, the distance where the body is placed in reference to the datum level is our height. So the key thing under this point is to note this formula of potential energy. which equals to mgh. My next level is discussing on kinetic energy, and kinetic energy is the energy possessed by a body due to its state of motion. And this is the formula. Kinetic energy is equals to a half mv squared. And now, observe this diagram I'm going to draw. When the object is at this point, it possesses potential energy. And when the object, this was an height, and when it is pushed down, the object will move downwards. And when it moves downwards, the potential energy here will totally be converted to kinetic energy. Due to that state of motion, it has moved from a point here to this lower point, this next position of an object. Initially, the object was at this point, and after displacement, it moves downwards along this height, and all the potential energy at this level will now be converted to kinetic energy. And here we say potential energy equals to kinetic energy, and potential energy is mgh equals to kinetic energy, which is a half mv squared. Then this will cancel this because it is the same object that has been displaced. Mass will cancel mass. We are going to remain with gh equals to a half m is going to go a half v squared. After that, we are going to multiply both sides by 2 to remove the fraction part. And there we are going to have 2gh equals to v squared. Therefore, velocity, that is v alone, equals to the square root of 2gh. And this is also another important equation, our second equation. And this equation, you have to know everything about it. What V represents velocity. G is the gravitational pull of the Earth. That is, G is always 9.81. This is the quantity of G. And H is the height. You'll be given the height, this one. After understanding kinetic energy, let's go on and discuss strain energy. So, strain energy refers to energy stored when a body is deformed. This is the energy stored when a body is deformed. So, let us assume that we had an elastic body of stiffness K. Stiffness is K. And it is deformed by a force P. P is now the deforming force. To a certain distance, and let's say that distance is x. X is now the distance of deformation, and therefore force, we know force, that is P, is equals to Kx. Force is equals to Kx. And here, work done is equals to strain energy. Therefore, work done is equals to a half px. And when work done is equals to a half px and p is equals to kx, therefore work done, which is the same as strain energy, equals to a half, then where there is px, replace this kx times x again, meaning work done equals to a half kx squared. So this is it. Hopeful that the video has helped you understand what is meant by kinetic energy, strain energy, and even the potential energy. Please don't fail to subscribe into the channel and like the video.